All right, I hear the recording in progress, so we'll go ahead and start it. Okay, so continuing on with 3.3. Okay, I hope to finish up 3.3 today. If not, I still have tomorrow. We're okay. And tomorrow you get your next quiz. Okay, so the quiz will be stuff on 3.2 and 3.3. Okay, and as usual, once I give you the quiz, you have until 11:59 p.m. tomorrow evening to do it. So you got the rest of the afternoon, rest of the morning and afternoon to finish it. So hopefully that's not going to be an issue. All right, so let's pick up where we were. So mark this off. Okay, so we're here, 3.3. All right, so we're using the rational zeros theorem. We said from last time, rational root theorem or rational zeros test given a polynomial. If there are any rational zeros, fractions, p over q, they have to look like this: plus or minus factor of the constant term divided by factor of the leading coefficient. Okay, you don't have to look at any of the in-between things. You only have to look at leading coefficient and the constant. Okay? The rationals have to be of the form factor of the constant divided by factor of the leading coefficient. And something else that we learn is, let's say if you have a fourth degree polynomial, you have to have 4 zeros, and there's going to be 4 factors. Okay? If you have a fifth degree polynomial, there are 5 zeros. And by the way, when we say 5 zeros, that allows for multiplicity. Okay, so that's accounting for repeated roots. So there has to be 5 zeros, and there also has to be 5 factors. And again, accounting for multiplicity in this particular case. All right, so find rational zeros and determine any irrationals and factor the polynomial completely. Now, your goal for most of these is to get down to a quadratic second degree. Once you get the equation down to a second degree, then you can always use a quadratic formula if you cannot factor it any further. But third degree or higher, you're stuck trying to find rational zeros, okay, by using the rational root theorem, as the case may be. Okay, so I'll show you how some of those would work. Okay, so 19, whoops. Trying to get this thing in focus here. This thing doesn't always want to focus on me. Here we go. X cubed minus 3x squared plus 4. Okay, now, yes, I could play the rational root theorem game where you have plus or minus a factor of 4 divided by plus or minus a factor of 1. So that means you would have to try plus or minus 1, plus or minus 2, plus or minus 4. Fortunately, I see the coefficients are 1, -3, and 4. I know some combination of 1, 3, and 4 gives me a 0, right? 1, 3, and 4. So there it's probably good to guess. Now, I notice that 1 doesn't work. 1 minus 3 plus 4, that isn't 0. But it looks like -1 is going to work, right? Because -1 cubed is -1, minus 3 times -1 squared is -3, plus 4. So that gives me 0. In other words, P of -1, -1 cubed minus 3 times -1 squared plus 4 is -1 minus 3 plus 4 equals 0. Okay, so if I plug in -1, I get 0. That tells me that x plus 1, not x minus 1, x plus 1 is a factor, right? That was the theorem that we had yesterday. Once I divide out x plus 1, I'll get no remainder, and then whatever's left behind will be second degree. Once I have second degree, I can either factor or use a quadratic formula, right? So that's the situation that we're at. Okay, so now I'll do long division on x cubed minus 3x squared plus 0x, right? There's no x term, so we have to count it as a 0, plus 4 divided by x plus 1. And I'm anticipating no remainder, and as you can see, there is no remainder. Let's double check. Okay, x into x cubed, x squared. Now take x squared times this whole thing, x cubed plus x squared. Subtract in parentheses. That minus that is nothing. -3x squared minus x squared is -4x squared. Bring down to 0x. X into a -4x squared, -4x. Negative 4x times this whole thing is negative 4x squared minus 4x. Subtract, got to watch out for all the negatives, minus parentheses. That minus that is 0. Negative 4x squared plus 4x squared. 0 minus a negative 4x is 4x. Bring down to plus 4. X into 4x plus 4. 4x plus 4. 4x plus 4, no remainder. So this thing factors into x plus 1, x squared minus 4x plus 4. And now this is very easy to factor. I do recognize that as x minus 2 squared. And so there's, okay, so the original polynomial, there's going to be 3 factors. Okay, and here they are. X plus 1, x minus 2, or we can say x minus 2 squared. Okay, so if it's a third degree polynomial, there has to be 3 factors, and there has to be 3 zeros. The 3 zeros are negative 1, 2, and 2, or we would say negative 1 multiplicity 1, and 2 of multiplicity 2. All right? So whatever degree of the polynomial you have, if you have integer coefficients, okay, then we can do the rational zeros theorem. Okay, but whatever the degree of the polynomial is, that determines how many roots and how many factors. Right? So if you start off with 7th degree, which I'm probably not going to have you do too many of those unless it's very easy. If you have 7th degree, you have to have 7 zeros, and you also have to have 7 factors. Okay. Okay, 21 is definitely harder because it's 4th degree. 2x to the 4th minus 3x cubed minus 3x squared plus 2x. Okay, so it's 4th degree. Therefore, there's going to be 4 factors. And there's also going to be 4 zeros. By the way, we're not guaranteeing we can always get them. Okay, and you might have to go to the complex realm. So we're back to doing complex numbers again, a plus bi. Okay, but there has to be 4 zeros and 4 factors. Fortunately, in this case, it's easy to factor out x. So first, let's take out an x. 2x cubed minus 3x squared minus 3x plus 2. So I know x equals 0 is already a root. And beyond that, we got to use our rational root theorem. Okay, so the possible rational zeros are plus or minus a factor of the constant, 2, okay, not too bad, divided by factor of the leading coefficient, which is also 2, which means plus or minus 1, 2, divided by 1, 2. And we can list them all. If I take 1 and 2 and divide it by 1, I have plus or minus 1 and plus or minus 2. Now I'll take 1 and 2 and divide by 2. So that's plus or minus a half and plus or minus 2 over 2. But then I realize, oh, 2 over 2 is 1. I already got that. Okay, so I have to try these 6 numbers as possible rational zeros. Okay. Fortunately, and sometimes you can kind of guess from the original, 2, 3, 3, and 2. Let me ignore the signs for a moment. 2, 3, 3, and 2. If I do it the right way, I think I can get a 0. Right? If I can get the 3s that cancel out, and I can get the 2s that cancel out. Okay, so I notice 1 doesn't seem to work. If you plug in 1, it's not going to work. You get 2 minus 3 plus 2. But negative 1, let's try negative 1. P of negative 1. 2 times negative 1. Let's see. Where was I? Oh, yeah, I'm looking at this. 2 times negative 1 cubed minus 3 times negative 1 squared minus 3 times negative 1 plus 2. That's negative 2 minus 3 plus 2. It is equal to 0. So just like the previous problem, when I plug in negative 1, I get 0. P of negative 1 is 0. Therefore, x plus 1 is going to be a factor. And once I divide out x plus 1 from a cubic, I'll have a quadratic. I'll have a second degree. And once I have second degree, I'm home free. I can either factor or use a quadratic formula, as the case may be. So do my long division. X into 2x cubed, 2x squared. 2x squared times this whole thing, 2x cubed plus 2x squared. Subtract. Cancels out, minus 5x squared. Bring down to minus 3x. x into a negative 5x squared minus 5x. Negative 5x times x plus 1, negative 5x squared minus 5x. Subtract. Yeah, you got to be careful. There's all these negatives all over the place. Negative, negative, negative. These cancel out. Negative 3 minus a minus 5, negative 3 plus 5, 2x, bring down to 2. Do it again. X into 2x plus 2. 2 times x plus 1, 2x plus 2, no remainder, which is what we're anticipating. All right, so we're getting there. So the original polynomial, we took out an x. We now have an x plus 1, and then 2x squared minus 5x plus 2. And that looks factorable. So x plus 1, 2x minus 1, x minus 2, and now the polynomial is completely factored. All right, so from the get-go, 4th degree. That means there's going to be 4 factors. Here they are. And it's going to be 4 zeros. The 4 zeros are 0, negative 1, 1/2, and 2. Right? And a quick side note, these do satisfy the possible candidates of rational zeros, don't they? Okay, negative 1 was on my list. 1/2 is on my list. And 2 is also on my list. Okay. But if I got, let's say, 3, there's something wrong because 3 is not even on my candidate list. Okay, so if there are any rational zeros, it has to come from this list. And it did. Okay, except for the 0, which we already took care of. Okay, negative 1, 1/2, and 2. Negative 1/2 is here somewhere. Right, negative 1/2, negative 1, and positive 2. So they're all there. Okay. All right, so that's the way the game works here. Okay, 25 is actually much nicer in some respect. 25. X cubed plus 2x squared minus 4x plus 1. The leading coefficient is 1. The constant is 1. That means the only things I have to try are plus or minus 1. Oh, that's nice, right? Because the way the rule works is plus or minus factor of the constant. So what are the factors of 1? Well, it's only 1. Divided by a factor of the leading coefficient, 1. So I only have to try 1 and negative 1. You can probably tell right away that 1 works, doesn't it? If you plug in 1, 1 plus 2 minus 4 plus 1 is 0. Therefore, x minus 1 is a factor of p of x. So I divide it out. X cubed plus 2x squared minus 5x plus 1 divided by x minus 1. Okay, x into x cubed, x squared. X squared times this whole thing, x cubed minus x squared. Subtract, this cancels out. 2 minus a minus 1 is 3, 3x squared. Bring down to minus 4x. How do you go from x to 3x squared? 3x. 3x times this whole thing, 3x squared minus 3x. Subtract, got to be careful here. That cancels out. Negative 4 minus a negative 3, negative 4 plus 3, negative 1x. Bring down to 1. How do I go from x to a negative x? Multiply by negative 1. And negative 1 times that is negative x plus 1. They cancel out. So no remainder, which is what we anticipate. So p of x is x minus 1, x squared plus 3x minus 1. This is not factorable. So what do? Quadratic formula. All right, so right here, I'll just write quadratic formula and I'll leave it to you to figure that out. Okay. Okay, now I'm going to digress, take a time out. Doing this long division, I mean, it's fine, it works, but it's very tedious. we have a nice method, something called synthetic division. Okay. Synthetic division gives you the same answer, but it's a lot quicker and less messy. It only works when you're dividing by a first degree polynomial, such as x minus a. Okay. So it doesn't work when I'm dividing by x squared or x cubed or something like that, only by x minus 3, x plus 4, something like that. Okay, so what is this weird synthetic division? Let's look back at the problem we just did. So same division as above, that means this. All right. When we did the long division properly, notice this is all x cubed, this is all x squared, this is all x, this is all constant, right? So you have to write x cubed quite a bit, x cubed, x squared, and x and 1. Okay. What if we say, okay, I'm not going to write down the x cubed or x squared or the x. I'm just going to leave it out. I know they're there, but as long as I keep everything lined up. Okay. So if I know that this is dedicated for numbers, everything here is dedicated for x, everything here is dedicated for x squared, everything here is dedicated for x cubed, I'm just not going to write the x cubed, x squared, x, and so on until the very end. I know that I'll just write the coefficients, not even write the x cubed, x squared. They're there, and I'll write it at the end, but you know, it got tedious. Let me just forget about it. Okay. Another thing I noticed, this kind of get messy, right? Negative, parentheses, negative. We're supposed to subtract. So sometimes you get a double negative. It's a little bit clumsy. Subtract, subtract. Okay. Instead of subtracting, how about I'll say I'll add the opposite, which is what subtraction really is, right? Subtraction is the adding of an opposite. So if you ever go a minus b, you can always think of it as a plus negative b, right? And I'm guessing a lot of you might say, well, I mess up a lot when I do this because I get a double negative. I mean, I'll mess up like that too. Or it's like we're saying, well, I'd rather not subtract. Let me add the opposite, which means instead of subtracting, we will add the opposite. Instead of having a negative one, I'll make it a positive one. So watch what happens. I can barely, well, maybe not. If I make it smaller. Okay, sorry, I'm making it smaller just so you can see. X cubed plus 2x squared minus 4x plus 1. I'm just going to put 1, 2, negative 4, 1. Try to make it just big enough so I can see both of them at the same time. X cubed, 2x squared minus 4x plus 1. 1, 2, negative 4, 1. It's the same information, is it not? This is numbers, x, x squared, x cubed. I'm just not bothering to write the x cubed, x squared, and so on. And instead of x minus 1, again, I'm not going to write the x. I'm going to put a positive 1. I changed the sign. Now, if this had been x plus 1, you put a negative 1 here. X minus 1 here means put a 1 here. Okay, so one more time. Don't bother putting x cubed, x squared, x, and so on. Just put the coefficients, 1, 2, negative 4, 1. We still know this is units. This is x, x squared, x cubed. And I put a 1 here. Okay. Now here's the way it works. By the way, notice what I'm doing here. This is way more compact and a lot less writing than all this. Right? Look at all this. I have to keep writing x, 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 x squared, x squared, x squared, x squared, x cubed, right? Just say, don't bother writing all that. I know it's there, but we'll save it until the end. What we're really doing here is adding, multiplying, adding, multiplying, adding. Okay, so how do I do this? Okay, this x minus 1 changes to just 1. Okay. So rather than subtracting, we're adding the opposite. Okay, 1. Okay, now multiply. 1 times 1, 1. Add. Don't subtract. We're adding because we're adding the opposite. 3. Multiply. 1 times 3, 3. Add. Negative 1. Multiply. 1 times negative 1, 0. I draw a line here. This is my remainder. This new polynomial is depressed by 1 degree. It used to be 3rd degree, so it's 2nd degree. So how do I read this off? X squared plus 3x minus 1. Exact same answer. Okay. But notice how much more compact it is. I get the same information. I didn't have to write all the x's and all the x squareds and all the x cubes, right? Okay. And instead of getting mixed up in my brain by keep remembering to subtract, I say, why don't I just add the opposite? So instead of putting a minus 1, let me make a plus 1 and add. Okay, so put down the 1, then it's multiply, add, multiply, add, multiply, add, right? So 1 times 1 is 1, add 3. 1 times 3 is 3, add negative 1. Multiply, add. Read these off as x squared minus 3x minus 1. Exactly the same answer as you got over here. Okay, so this is called synthetic division. Very nice, as you can see. And we'll do more examples of this, of course. And yeah, what do you do after that? Quadratic formula. Not factorable. So A is 1, B is 3, C is negative 1. So quadratic formula to the rescue, right? Negative B plus or minus the square root of B squared minus 4AC all over 2A. So negative 3 plus or minus the square root of B squared is 9 minus 4 times A, which is 1, times C, which is negative 1, all over 2A, 2 times 1. So this becomes 9 minus a minus 4, 9 plus 4. So negative 3 plus or minus radical 13 all over 2. And there we go. Okay, so how do I write my final answer? It's going to be quite messy. I'll show that to you in just a second. Yeah, question.
So this works. This example, it just ends up having to do a quadratic formula, right?
Correct.
So it works for any okay, yeah. And what was my other question? So initially you write out your so just summarize this. You write out your coefficients, and then you take one factor that you know is there, and then you add the opposite of the number in the x minus 1 form, in the x minus 1 form, right?
Mm-hmm.
I'm just confused. So it's just like, so wait, okay, so in that case, the first thing you did, you added 1 and nothing, right? When you're doing, go down your synthetic division, your first row or column, your first column, you added 1 to nothing. Why
Correct.
did you? Okay.
You just come straight down. You notice that happens for all these other ones too. The first number just comes straight down. But yeah, you're adding nothing. You're basically adding nothing. Then you start multiplying, adding, and so on.
All right.
Okay. All right. Hopefully it becomes more clear as we do more examples, and we'll see. Okay, so yeah, how do I write my answer?
It really doesn't matter which way we do it, though, right? You're not going to ask us to like do it this way on the test specifically, are you?
You mean synthetic division?
Yeah.
I might. I want you to know this. Okay. Now, if I don't say, you take your pick. I mean, I prefer this. I mean, it's a lot less writing. Now, if you're comfortable with this and it's fine and dandy, that's good. But look at how many times I have to write x, right? X. How many times I write x squared? I say, okay, forget writing it. I know everything here is an x. I know everything here is an x squared. I know everything. I'm just not going to write it until the very end. And there it is. I get the same answer. Since I know this is dedicated for numbers, x's, x squared, x cubed, as long as I keep it all lined up, right? So everything here is all x's. So I'm not going to write the x's until the very end. I know this is all x squared, so I don't keep writing it until the very end, and so forth. As long as I don't mix it up, right? I don't move this over to there, move that over there, then hopefully it all works out. And I'll show you more examples of this.
Okay. All right, thank you.
Okay, you're welcome. And now, how do I write my answer when I get irrational solutions like this? So what we said again at the beginning was, what do we have? A third degree polynomial. Therefore, there's going to be 3 solutions. They're not all nice. And there's going to be 3 factors. And in this case, they're not all nice either. Okay, the nice one was x minus 1. Right? I now know what the 3 solutions are. They're 1. Where was it? Yeah, 1. And these 2 guys, negative 3 minus radical 13 over 2, and negative 3 plus radical 13 over 2. Those are the 3 solutions. Nobody said they were going to be nice. And now, how do I write my factors? I think you're probably okay in the x minus 1, right? If you did the long division, all right, we got x minus 1 as a factor. And you can tell, right? If you plug in 1, you get 0. We're looking for zeros. If you plug in 1, you get 0 from x minus 1. So if 1 is a solution or 1's a 0, that means x minus 1 is a factor. So by the same logic, if I go x minus whatever's behind here and x minus whatever's behind here, I get factors. If it was nice like 1, I would just put x minus 1. Or pretend behind this finger was -7. I would put x minus a -7 or x plus 7. So in my mind, I'm going to go x minus that mess. And x minus this mess, x minus that stuff. So here are the 3 factors, x minus 1, x minus all this junk over here, -3 minus radical 13/2, and then x minus all this stuff, -3 plus radical 13/2. And then just a little bit of cleanup. Here I decided to distribute the negative, right? Negative, 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 make them all positive. So x minus 1, x plus 3 plus radical 13/2, x plus, let's see, what did I do? Oh, I distributed the negative. So x plus 3 minus radical 13 all over 2. Okay, so this thing factors. Here's the complete factorization. Nobody said it was nice. Definitely not nice. But here are the factors. And the zeros are 1. And yeah, the opposite of that, which is that one. And the opposite of that, which is this thing. Okay. All right. Now I'll try to help demonstrate that on the hardest one, 23, 5th degree. That's a mean trick, right? So 23, 2x to the 5th plus x to the 4th, blah, 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 blah. There should be how many zeros? 5 0. There should be how many factors? 5 factors. Okay. They may or may not be easy, but what can we do? Try it. So here's the original polynomial. All right, let's try the rational root theorem. The possible rational zeros, plus or minus factor of 3. You can say -3, but usually we just say the positive, okay, because we're doing plus or minus anyway. I get this thing to focus on me. So plus or minus factor of 3, plus or minus factor of 2. Fortunately, there aren't that many things to try here. Side note, what's not really nice is if this thing here came out to be, let's say, 12. 12 is pretty bad because 12, the factors of 12 are 1, 2, 3, 4, 6, and 12. There's a lot more possibilities, right? But here, just plus or minus factor of 3, plus or minus factor of 2. What are the factors of 3? 1 and 3. What are the factors of 2? 1 and 2. Okay, so how do I make my list? I take the 1 and the 3 and divide it by 1. Well, if you divide by 1, you just leave it as plus or minus 1, plus or minus 3. And you take the 1 and the 3 and divide them by 2. So plus or minus a half, plus or minus 3 halves. Okay. So these are the quote unquote only numbers to try. I mean, that's still a big list. 1, 2, 3, 4 times 2 is 8. There's only 8 things to try. Of course, that's still tiresome, but that's a lot smaller than infinity, right? There are infinitely many rational numbers. This tells you the only candidates. These are the only things running for office, so to speak. Now, none of these still might work. But if there are any rational zeros, they have to come from this list. So automatically, I know 2 is not going to work. 4 is not going to work. -80 isn't going to work. 5/7 isn't going to work. Out of those infinitely many rational numbers, it has to come from this list. And when we look at our final solutions, we'll check to see any rationals do indeed come from this list. By the way, you might say, way back here, what about these? Yeah, but these aren't rational. Okay, the only rationals we had were plus or minus 1, and that's correct. we got 1. These two are not rational. The only rationals we can have are from this list, plus or minus 1, plus or minus 3, plus or minus half, plus or minus 3 halves. Okay, now the nicest thing to try is 1. Okay, and I believe 1 worked. The nice thing about 1 is 1 raised to any power is 1. 2 plus 1 is 3, minus 12 is negative 9, plus 10 is 1, plus 2 is 3, minus 3 is 0. Okay, so 1 should work. So let's try it. Okay, now I could do 2x to the 5th plus blah, 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 divided by x minus 1 and do all this stuff. It would get long. You'd be writing a whole bunch of x to the 5th, x to the 4th, x cubed, blah, 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 blah. Okay, this new synthetic division, notice what we're doing. We're just putting what? Notice 2, 1, negative 12, 10, 2, negative 3. Saving a lot of writing, right? So look at all this. Look at how many times I had to write x, x squared, x cubed. We just say, forget writing all the x's. This has the same information as long as we all agree, right? This is focus. Come on. We agree, this is units, x, x squared, x cubed, x to the 4th, x to the 5th, right? Units, x, x squared, x cubed, x to the 4th, x to the 5th. Okay. Now in numbers we went what? Ones, tens, hundreds, thousands, 10,000s, 100,000, so on, right? In algebra, we have units, x's, x squared, x cubed, x to the 4th, x to the 5th. And yes, I could divide by x minus 1, just like over here. And then you'd have to keep subtracting and doing the double negatives, right? So we're going to say, well, forget that. Let me just add the opposites. So just put positive 1. In case you're wondering, folks, I don't know why it goes out of focus. I'm not pressing any buttons. The machine just decides to do it on its own. Okay, yeah, the first one comes down. Now I just keep doing multiply, add, multiply, add, multiply, add, multiply, add, so on. Okay, multiply, 1 times 2 is 2, add, 3. This is equivalent to subtracting over here, subtracting the original, I'll just add the opposite. Multiply, 1 times 3 is 3, add, negative 9. Multiply, 1 times negative 9, negative 9, add, 1. Multiply, 1 times 1 is 1, add 2 plus 1 is 3. Multiply, 1 times 3 is 3, add 0. Draw the line here. So now the 5th degree gets to press down to 4th degree. How do I read this? Okay, so I got x minus 1, 2x to the 4th, 3x cubed, minus 9x squared, plus x plus 3. If you want to convince yourself of that, go ahead and do the long division with all the x to the 5th and 4th and 3rd and blah, blah, blah. You'll get the same answer. Okay, I decided to try 1 again because I noticed 2 plus 3 is 5. 5 minus 9 is negative 4. Plus 1 is 3. Is negative 3 plus 3 is 0. So I can do 1 again. So it looks like I'm going to get a 1 of multiplicity 2, or at least 2, I should say. So I get x minus 1. So 1's going to work. And instead of writing all the x's, just write, notice, 2, 3, negative 9, 1, 3. It means the same thing as 3 1s and 1x and negative 9x squared and 3x cubed and 2x to the 4th. We're just not writing it. Okay, yes, first number comes straight down. Multiply, 1 times 2 is 2, add, 3 plus 2 is 5. Keep doing the same thing. Multiply, add. Multiply, add. Multiply, add. Okay. If this last number is a 0, that means the remainder is 0. Now, if this last number is a 1 or 3 or negative 5 or whatever, that means there's a remainder, which means you don't have a factor. All right, this used to be x to the 4th. It's now down to x cubed. So let's see, I got an x minus 1 twice, multiplicity at least 2. So I have x minus 1 squared. And how do I read this? 2x cubed plus 5x squared minus 4x minus 3. And what do I notice? If I plug in 1, 2 plus 5, 2 plus 5 minus 4 minus 3 is 0. 1 works again. Do it again. 2. Multiply. 1 times 2 is 2. Add. 5 plus 2 is 7. Multiply. 1 times 7 is 7. Add. 3. Multiply. 1 times 3 is 3. Add 0. It works again. So notice 1 worked here. Multiplicity 1. 1 works here. Multiplicity 2. 1 works here. Multiplicity 3. So I now have x minus 1 cubed. And how do I read this? 2x squared plus 7x plus 3. I now have a quadratic equation. Once I have a quadratic, I can do the quadratic formula or factor. Looks like this thing does factorize. So I'll keep going with the factorization. X minus 1 cubed. Let's see. Looks like I got 2x plus 1, x plus 3, double check with FOIL. 2x squared plus 6x plus 1x. Yeah, it works. All right, so this original 5th degree polynomial has 5 factors. Here they are. X minus 1 cubed, that's multiplicity 3. 2x plus 1, x plus 3. There should be 5 zeros. What are the 5 zeros? 1 of multiplicity 3. Set that equal to 0, that's negative a half. And set that equal to 0, that gives me negative 3, right? Okay, and the problem's finished, but a quick double check. My rational roots are 1 of multiplicity 3. Is 1 on this list? Yes, it is. Negative a half. Is negative half on this list? Yes, it is. And negative 3. Is negative 3 on the list? Yes, it is. So I would be surprised if we got a 4. 4 is not supposed to be there. 2 is not supposed to be there. The only ones we got are from my list. I got 1, well, 3 times. 1, right? And negative a half is there somewhere. And negative 3 is also there. Okay. So there we go. Okay, how much time do we have? A little bit left. Okay, I'll set you up with 35, and maybe I'll end with that. Find a 4th degree polynomial that has zeros at x equals 0, x equals 1, x equals negative 1, x equals negative 2, and whose x squared term has coefficient 5. Now, how do I do that? All right. So it's 4th degree. They tell me what the 4 zeros are. 0, 1, negative 1, and negative 2. But the x squared term has a coefficient of 5. All right. So the polynomial is x from the 0, x minus 1 because of the 1, x plus 1 because of the negative 1, x plus 2 because of the negative 2. We're going backwards. We're building a polynomial. And a constant k, where k is non-zero. Okay. If I just look at this, right? Say, what are the zeros? Oh, 0, 1, negative 1, negative 2, right? Well, we're just going backwards. Here we're given the zeros. Now build the polynomial, so to speak. So x, x minus 1, x plus 1, x plus 2. But there could be a constant in front, like 3 or 7 or negative 80. Okay, that wouldn't change this. How do I find k? Well, the hint is they tell me that the x squared coefficient is 5. So I have to multiply all this mess out. Okay, I multiplied on x minus 1, x plus 1. That's a difference of squares. So kx, x squared minus 1, x plus 2. Then I distribute the x to the x squared minus 1. So x times that is x cubed minus x, x plus 2. Okay, equals k times, then I FOIL all this out. So first, x to the fourth, outer 2x cubed, inner negative x squared, last negative 2x.
Can't you just multiply the x squared, like the entire parentheses, by 5? So we have x squared minus 1, right? That's one of our factors. Can't you just do 5 times x squared minus 1 and then insert that into your equation?
5 times x squared minus 1, it doesn't necessarily work. I mean, I know that there's a 5 here, but we're trying to find what this k is ultimately. Okay, if I multiply by 5, that doesn't guarantee what the coefficient is. Okay, so let me just finish this and see if that answers it, and if not, you can ask again. But anyway, so I FOIL this out. Now let me distribute the k. Kx to the fourth plus 2kx cubed minus kx squared minus 2kx. Okay, so in other words, k times all this stuff now comes out to be this. We actually don't care about any of these except for the x squared. Okay, it says the coefficient of x squared has to be 5. It's negative kx squared after I multiply all this mess out. So how can I make the coefficient 5 if I let k equal negative 5? So k is negative 5. If k is negative 5, then the coefficient of x squared would be 5. So put the k's negative 5 back in, and that's my final answer. So the final answer is negative 5x, x minus 1, x plus 1, and x plus 2. Okay. So this means if I multiply all of this junk out, the x squared coefficient would be 5. And what are the zeros? 0, we can tell from there. 1, you can tell from there. Negative 1, you can tell from there. And negative 2, you can tell from there. Okay.
I mean, like when I did this problem, like, I kind of just guessed and tried that, and like when I graphed it, it had all of the things necessary for the problem, but it still, like, it had all the zeros were correct, and my coefficient, but like, so yeah, so like when it says coefficient, like my final answer was x times parentheses 5x squared minus 5 parentheses open parentheses x plus 2 and parentheses. That the coefficient to x squared is still 5, and all my zeros are correct. So is that a wrong answer still, or no?
I'd have to see what you did, and I didn't have a chance to, see exactly what you were talking about.
All right, I'll come to your office hours.
Yeah, but this is the technique. I mean, this is the technique to work this kind of problem out rather than guessing.
Okay.
So I'll be more dogmatic. To work this problem out, you should do it this way. Okay. I mean, you might be able to get it by guessing. In this case, the guess is pretty reasonable, but I could give you something where it's almost impossible to guess, but the technique here would still work. Okay.
Good point. Thank you.
Yeah. I mean, you're right. You probably could guess this, but let's say k came out to be 316.521414. There's no way you or I are going to guess that. But if you follow this technique, you'll still be able to come up with it. Yeah. Okay. All right, folks. So I think I'm actually done. So schedule-wise.
Really quick. The question said 5x. Where did you get negative 5x from?
Yes, let me finish what I was going to say here.
Okay, sorry.
So I'm finished with what I was going to lecture up to here. So tomorrow I'll give you a quiz. Buffer day, it means I'm going to probably get started with the next section, 3.4. The next section, 3.4, is definitely tougher. We're doing something called rational functions. And the quiz will be on 3.2 and 3.3 stuff. Okay. Yeah. Bonnie, what was your question again down here?
Sorry, I didn't mean to interrupt you. I apologize. Has coefficient 5. So where does the negative 5 come from?
Okay, so all of this comes out to be this stuff. Okay.
Yeah.
Okay. And that means negative kx squared has to equal 5x squared. So the thing behind my finger, which is negative k, that has to equal 5. In other words, negative k equals 5.
Oh, so
Well, if negative k is 5, then
minus-
k is negative 5.
yeah, minus a negative 5 equals 5. I see. Okay.
Yeah, negative k has to equal 5. So k is negative 5. Whoops. Okay. All right. Almost out of time. Anything quick? Otherwise, we're done for today, folks. All right. So that'll do it for today. So have a good day and see everybody next time. Okay. Bye, everybody.